Hello guys and welcome to this video today on problems in 3 dimensions, building on the measurement and geometry stuff for the Further Maths course. Now don't worry about it. If you're not doing Further Maths, no big deal. Trust me, the work is universal. Maths, as they say, is a constant. Small lol, big lol. What are we dealing with? Problems in 3 dimensions. Which problems? Well, Pythag, trig, sine rule, cosine rule. Hopefully they're all going to be in the 3 fairly large questions I'm about to do. Now, obviously, all of these videos are on MaffsGuru.com. If you haven't been over there, you can search by textbook and chapter, and there are downloadable notes. Absolutely free to sign up. Head over there. Could be the best thing you've done today. Alternatively, having breakfast could be the best thing you've done today. I don't know. It'd be fairly sad, actually, if you went over to my website and it was the best thing you did today. You need to get out more. Okay, so problems in 3 dimensions. Basically, the whole point of mathematics is that we teach you the framework that you can apply over and over again. All the work we've done so far is on triangles, right angle triangles and non-right angle triangles. So all of the questions I'm about to do, can you try and beat me to see where the triangles are that we're going to deal with? When you see the triangle, ask yourself the question, is it right angled or is it not right angled? Because ultimately, once you know that, you apply the right amount of theory with your CAS calculator and you should be able to get all of these answers. Now, the examples I'm using are extracted with permission from the Cambridge Further Maths textbook. And thank you very much, Cambridge, for allowing me to use your examples. You guys absolutely rock, and your textbook is really second to none. Okay, so here we go. A, B, C, D, E, F, G, H. This is not an exercise in reading the alphabet. Is a cuboid. All right, not a cube, a cuboid. A cuboid is basically a rectangular 3-dimensional shape. Find the distance dB. All right, first things first. So I'm going to highlight where dB is. It's this distance here. All right, so can I see a triangle there that might be right angled? And in many cases, this is a perspective thing, looking down on the top. If I actually look down on the top, I'm going to end up with, here is the plan view, and I'm going to have A, B, C, and D. Do I know anything about the length AB? I do, it's 10 centimeters. Do I know anything about the length BC? I do, it's 8 centimeters. And they want the length going across here. Well, it's a length. Can I see a right angle triangle? I can. Do I know the lengths of said triangle? I do if I move that 8 to there. And so finding that length is going to be a Pythagoras question. So part A, we now know then that dB squared, and I'm going to write these like this for the moment. I'm going to scroll up a moment, is equal to 8 squared plus 10 squared, which is 64, plus 100, which is 164. So dB, if you remember, is going to be the square root of 164. Now, I'm going to fire up my CAS calculator, and I'm going to work out, he says, bring up the keyboard, the square root of 164. Hit enter, and that gives me a value of 12.81 centimeters. Don't know that it gave me any, no it didn't. So I'm going to round all my values at the moment to 2 decimal places. Why is this going to be important to me? Well, this value here, the square root of 164 is what we call an exact value. And I can use that in later parts of the diagram if anyone tells me to find dB. What I wouldn't want to be doing is using my rounded value, because rounded values start to introduce rounding errors. That is not a good idea. So the distance HB, so let's highlight the distance HB. Where are you? H to B, that's this distance here. Well, hold on a moment. Now, this is doing something in maths that I really, really don't like. I can see I've got a triangle here from H to D to B and back again. But it's going to require that I use my previous value. Now, in most of maths, we try not to do that, because if you've made a mistake on one value, you're going to ripple through that mistake through the rest of the questions. Thankfully, we have consequential marking over here in Australia, which sort of accounts for that, but I prefer not to make the mistake in the first place. So distance H to B, let's draw my triangle, because I always draw a diagram just to make sure I can. H to D, do I know the distance? I do. It's 7 centimeters tall. Why? Because that's the height of my cuboid, and H to D is that height. What else do I know? I now know the length of D to B. So dB is, I'm going to actually write it as the square root of 164. That's going to become important in a moment. And I want to find the distance HB. So let's call that, well, let's call it HB basically. So scrolling over a moment, so we've got some room. I get HB squared is equal to 7 squared plus the square root of 164 squared. Now, do you see why I do it that way? Because the square and the square root cancel each other out. And rather than dealing with revolting decimals and incorrect values, I'm going to end up with 164. So it becomes 49 plus 164, which gives me 164 plus 49. Yes, I could have done it in my head, but I want to make sure. 213. So we now know that HB is equal to the square root of 213, and just so that I can write the value down, gives me a value of 14.59 and centimeters. So I've got another distance. How is this going to help me? Well, let's go back to the next part of the question. The magnitude of the angle HBD. So here is H, here is D, and here is B. Okie dokie, can we find the magnitude of that angle? Well, of course I can, because it's a right angle triangle. I'm going to end up using trigonometry. So for part C, we're going to draw my triangle. Now I only need to know 2 side lengths. And again, I'm going to use 7 and the square root of, whoops, not 14, 164. This is the angle I'm looking for. Now again, when it wants an angle and it's given 3 letters, the one in the middle is the one they're looking for. H to B to D. So here's H, B, D. The letter B was in the middle, and that's the angle they are looking for. Okie dokie. So we've got opposite and adjacent. So we now know the tan of my angle is equal to the opposite side divided by adjacent side. So theta is going to be tan to the -1 of 7 on the square root of 164. And fabulously, my calculator can do this for me. So go to trig. Let's do 10 to the -1 of a fraction. We're going to do 7 divided by the square root of 164. Close, I always do that, don't know why. Close my bracket in the right place, hit enter, and we end up with an angle of 28.66 degrees. Again, I'm going to leave that to 2 decimal places. Right, well, powering through this at this moment in time, what does it go on to say next? The distance HA. Okay, we're throwing a spanner in the works. We've got a distance HA here. Now, this is actually dealing or leading to the last part of this question. Can I find that? Well, yes, I have HD. I've got AD as values from my cuboid, so I can do that. H to D to A. Okay, so let's scroll up a moment. Part D, we want H to D to A. And what did we know that that was 7 there? And I think, if I remember rightly, this is where life gets challenging, is 8. And that is 8. So how do we find it? Again, it's a right angle triangle. It's a Pythagoras. No, it's yes, it's a Pythagoras question. My brain tried to mess with me then. So we get HA squared is equal to 7 squared plus 8 squared. I can do that in my head. 49 plus 64. Add those together. Yes, I could also do this in my head, but I'm not going to. That age-old cop-out, 113. So we know that HA is equal to the square root of 113, which is equal to the square root of 113, gives me 10.63. So 10.63 and centimeters. Now, why is this all important to me? I'm actually going to zoom right the way out and scroll it down, because it then says the magnitude of angle HBA. So I'm going to do part E here. And we want the magnitude of HBA. So here is H, here is A, and here is B. Now this triangle is not right angled, right? So it's not right angled. So that means we're going to use sine rule or cosine rule. To be able to do those, I need 3 sides or 2 sides and an included angle. All right, now as it turns out, we don't have an included angle. I want to try and find this angle here, so I'm going to call it theta again. But do I know the lengths of those sides? Well, I do, because I now know that HA is the square root of 113. I know that HB, I've got there, is the square root of 213, and I know that A to B is 10, and I have all the information I need, because this is going to be a cosine rule question. So we know that the cosine of angle B in this situation is going to be A squared plus C squared minus B squared, all on 2AC. And again, there is a video for you on this that you can go back to watch. So what do we fit in? So we want the cosine of angle B is equal to the 2 opposite sides, 213 squared plus 10 squared minus the square root of 113 all squared. Again, notice the reason I'm using these square roots is because the squares are going to effectively cancel them out, times 2 times the square root of 213 times 10. Right, putting that into my calculator, or rather, I'm going to simplify that first, because that's just going to give me 213 plus 100 minus 113 all on 20 times the square root of 213, which gives me 213, 313, 200 on 20 times the square root of 213. And remember, this is still the cosine of theta. And so if we want to find theta, we're going to do the inverse cosine of 200 on 20 root 213. Okay, my calculator can do that. Cosine to the minus 1 of bracket, fraction, put that there. Let's do 20 root 213. Put my bracket in the right place, which it still didn't because my calculator didn't move. Hit enter, and we get the value of theta is 46.75 degrees. And there we go. That has applied Pythag, some trig, and some sine and cosine rule to that one question. And here is our second question, and these are sort of questions that we use over and over and over again in exams. There are cuboids, there are pyramids, there are masts on towers and all sorts of different stuff. Work out these type of questions and I think you'll be set pretty much for every exam that we can hopefully ever throw at you, particularly with pyramids. So the diagram shows a square-based pyramid. Now that's the first trick. It's square-based, which means that length is 6, that is 6, that is 6, and that is 6. A lot of people miss that very important piece of information, strangely. So I'm going to write 6 there just so I know. The base has sides 6 centimeters long, and the edges VA, VB, VC, and VD are 10 centimeters long. So basically all of the diagonals, or the edges of my pyramids, are 10 centimeters long. Find the length of DB. So where is DB? Well, again, this is a nice, obvious one that they tend to do all of the time. It leads into being able to find the height of the pyramid. But if we look again at the plan view, we are going to have A, B, C, and D. We know that's 6 and 6. We want to find that length there. Is it a right angle triangle? I should hope so, because the base is a square, and so we can just use our Pythagoras theorem. Fabulous. So the length of DB squared is going to be 6 squared plus 6 squared, which is 36, plus 36, which is 72. So that means that DB is going to be the square root of 72. And again, we can fire up our calculator and we can work out the square root of 72 gives me the value of 8.49. So 8.49, and in this situation, centimeters. Now again, I'm not going to use that decimal value. I'm going to use this square root value because later on the chances are I'm going to square it and life is going to be good. So find the length of BE. Well, BE, where is E? E is actually smack bang in the center of that square. All right, now as it also turns out, it is directly below the highest point of my pyramid. Yay! So I already know where this is going. So the length of BE, so BE is basically a half of DB. And so I'm going to do a half of the square root of 72. And again, I'm going to leave that like that. I can divide by 2 here because it wants a specific answer. So it's going to give me 4.24 centimeters. Again, because I've done so many of these questions, I know where it's leading to. The length of VE, and there you have it, ladies and gentlemen. So now it wants the length of VE, which is this length here. I now have, well, I've been given EB, but they're trying to trick me because I also know that that's the same length of D to E, right? Because it's halfway along that line. And I know that this length here is 10. Do I have a right angle triangle? I should go. And so I have, he says, let's just zoom in just a little bit or zoom out so that I can now say and draw my triangle. I have this length here as 10. I want this length here as VE. And I know this length here is the square root of 72 on 2, right? It's the same as a half of root 72. How is that important to me? Well, I'm going to use, yes, once again, Pythagoras' theorem. Thank you, Mr. Pythag. Zoom in. So what do we know now? We know that 10 squared, don't get confused, they're trying to trick you here. They've actually given you the hypotenuse. 10 squared is equal to root 72 on 2 all squared plus VE all squared. Well, that's 100 minus, he says, taking away the square root of, oh dear me, I don't know why my 7s keep wanting to go to 2 on 2 squared is equal to VE squared. And let's see what happens. We are going to do 100, please, minus, and in brackets, well, there is my bracket, and a fraction, thank you very much, the square root of 72 divided by 2, close the bracket, and we go all squared. Thank you very much. That's going to give me the value of 82. Right, brilliant. So we now know that VE squared is 82. And in the same way, I'm going to say that VE is the root of 82. And let's actually work that out because the calculator wanted a specific length. And that's going to give me 9.01 centimeters. Yay! Scroll back up and see what else it wanted me to do. Find the magnitude of angle VBE. VBE. Well, this angle here actually is exactly the same size as that angle there, all right? So if you've used this 10 here, same. The angle, the triangle VDE and VBE are exactly the same. So I can actually use my previous diagram here because it wants me to find that angle there. How am I going to do that? Well, I could use my value I've got of VE, or I can just use trigonometry and know that this is my hypotenuse, this is my adjacent, and so in which case I'm going to use cosine. Let's just scroll out a little bit. So therefore, let's call that theta. So we now know the cosine of theta is equal to the adjacent, that's the square root of 72 on 2, all divided by my hypotenuse, which is 10. And again, that looks disgusting, but you can put it into your calculator. So I know that theta is going to be cosine to the minus 1 of all of that, which is root 72 on 2, all on 10. Now, I know we say you normally can't do fractions on fractions, but as I say, your CAS calculator can deal with this. So I'm going to go cos of the minus 1, and I'm going to do fraction, and hit the fraction button again. And what do you notice? I have a fraction on a fraction. So I have the square root of 72 divided by 2 divided by 10. Close my brackets, he says, putting my brackets in the right place, and piff puff poof, out comes 64.90 degrees. And I've just noticed that very last part there that says give all answers correct to 2 decimal places. Whew, just as well I did that. Now, wasn't that annoying? They put it there right at the very end. Why did you put it there in the question? Anyway, whole new discussion. Okay, this is a funky question because it's now actually not breaking it down into stages. What they're doing is they're basically saying, well, rather than step you through it line by line by line by line to get to an answer, we're just going to go straight to this is what we want you to find and ask you to deconstruct it. Okay, so a communications mast is erected at corner A. So this here is my communications mast. Of a rectangular courtyard ABCD, rectangle's good, means I'm going to end up with right angle triangles whose sides measure 60 and 45. We've got that. The angle of elevation of the top of the mast from C is 12 degrees. And this is where life gets interesting, because what they basically are trying to tell you is you need to draw a dotted line across the horizontal here, because remember, angles of elevation are from a horizontal and up. So this here is the angle that they're trying to tell me. Why is that dotted line going to be important to me? Well, guess what, ladies and gentlemen? You're probably going to have to find the length of that line, which we've done in previous questions. They're just not stepping us through it. Okay, so find the height of the mast. Okie dokie. So now, if I look, I've got a right angle triangle. I'm not going to draw it to scale, but it's not going to be too far off. This is point C, this is point A, and this is now H. It wants me to find this height here. What information have they given me? Well, they've told me that this angle here is 12 degrees, but I don't have any other information. So I've either got to find the length of that line from C to H, which is going to be nigh on impossible because I don't have enough information, or I can find that length there. Once I've got that, I can use trigonometry and life is good. Can I find C to A? I should cocoa, because again, I'm going to go back and do what I need to do. So breaking this down into a sub-calculation, here I've got my rectangle. I know that's C, D, A, and B. I know that's 45. I know that's 60. Can I find that length there? I should cocoa by using Pythagoras theorem. Marvelous. So we now know that AC squared, he says moving this over, is going to be 60 squared plus 45 squared. No way I'm doing that in my head. 60 squared is equal to, oh, I don't know what's going on there because I didn't hit the square button. 60 squared is 3,600. Yes, I could have worked that one out. 45 squared, no, not doing that in my head, is equal to 2025. Add those together, add 3600, and that's going to give me 5625. So AC is going to be the square root of 5625. Now, I don't need to actually do the decimal places for this one because they've not asked me for the length of AC. I'm just going to use that. There's no point actually doing it because I'm going to use that square root value because it's going to square in just a second, or it won't. So what do we now know? We know that that is the root of 5625. Do I have information that I need? Yes, I do, because I can now use trigonometry. Yes, I've got my adjacent and I've got my opposite, and there's my adjacent, or the opposite is what I'm trying to find. And so we now know that tan of my angle, which is 12 degrees, is the opposite side length, which is AH, divided by my adjacent, which is 5625. So we now know that AH, using a bit of algebraic manipulation, is equal to the tan of 12 degrees multiplied by the square root of 5625. Oh, tan, thank goodness. Can you imagine trying to do this without a calculator way back in the day? Yeah, and I know I'm old, but I'm not that old. Yeah, although my maths teacher always taught me about these things called log tables. Random things, I don't know. So there we go. We now know that the length of AH is 15 point, and it says give answers correct to 2 decimal places, 9, 4, and meters. So my mast is 15.94 meters high. Whew. Let's minimize my calculator for a moment. What does it go on to say? The angle of elevation of the top of the mast from B. So now it's asking for that little angle in there. So let's draw a quick diagram of what we have. So here's H, and here's A, and here's B. Do I know the length of AB? Yeah, I do. It's 45. That's the angle I want to find. Do I know AH? I do indeed. It's now the value we've got here. Now I'm going to write 15.94, but I'm going to use the value on my calculator because in this situation I don't want rounding errors. So once again, what do we know? We know it's a tan question. So we know that tan theta is the opposite, which is our value of 15.94 divided by 45. So theta is going to be tan to the minus 1 of 15.94 divided by 45, which is going to give me the staggering value, he says, loading up my calculator. Now again, remember, so I'm going to do tan to the minus 1 of my fraction. I'm going to copy all of that value in so I don't get rounding errors. I'm going to divide that by 45, move and close my bracket and hit enter, and I get the angle is 19.51 degrees. And there we go, ladies and gentlemen, 3 questions that really show all the ways we can apply sort of Pythag trig, sine rule, cosine rule to 3-dimensional problems. The trick there is, though, there's no trick. Find the right angle triangles, draw them in a separate diagram if you can, and life is good. All right, I am done. Thank you very much for watching. Leave a comment if you can. Sign up to my YouTube channel and give me a shout out on TikTok. If you actually could, I would be deeply grateful. Otherwise, hopefully I'll see you in another video. Take care of yourselves. Stay safe. Bye-bye.